Hello and welcome to today's lesson on rational exponents. This is covering topics in the standard 1.1a in Algebra 2, and it's going to cover questions under the lesson called Rational Exponents in Study Island. So as you're going through these questions and notes today, you can pause, rewind, and fast forward as much as you need to. I recommend that you take notes as you go, so if I go too fast, just pause. And then as you are working through the questions, you can pause at the beginning, work through the question, and see what you get, and then compare it to what I work out, and that way you can find your mistakes and learn from them. And so I'm looking forward to today's lesson, and there's just going to be one little trick that you're going to have to remember, and you should be good to go on these questions. So let's go ahead and take some notes. We can write radicals, so if square roots, cube roots, fourth roots, etc., as with the root symbol or as a fractional exponent. And so this lesson we're going to look at how to go between a fractional exponent and a radical. So just some vocabulary words is this is the radical symbol in the red. What's underneath the symbol is the radicand. And then if that radicand has an exponent, that's going to be the numerator. And then if it has an index, so if that was a square root, it would be an invisible 2. If it was a cube root, it would be a 3. Fourth root, it would be a 5. And that's going to be the denominator. So if I look here, as a fractional exponent, z is being raised to the 5/3. And so, but if I write that as a radical, that 5 is going to become the exponent underneath, and the 3 is going to become my index. And so that's just how you convert in between them. One other exponent rule we need to remember is if to remove a negative exponent, because it's not completely simplified until I have all positive exponents, I just simply take that and place the entire term in the denominator, and when I do that, it becomes a positive exponent. And so here it is, as with numbers, the 5 to the negative 2, that's the same as 1 over 5 squared. And if it was the other way around, if there was a negative in the denominator, you would move it to the numerator. So looking at this first equation, it wants me to take it, or question, it wants me to take it from a radical to a term that has fractional exponents. So this is a square root, so my index is an invisible 2. And then I'm going to have the 4 is what's underneath the radical symbol. And then I have a 6 as an exponent, so that's going to be the top of my fraction. And I have a 2 as an index, so that's the bottom of my fractional exponent. And you could simplify that 6 over 2 to just 4 to the third power. However, looking at my answers, this is where they stop. They don't simplify it any further, and my answer is A. Same thing here. I have a 3 that's underneath the radical symbol. I have an 8 is the exponent, that's going to be my numerator. And I have a 5 as an index, and that's going to be my denominator. And so that means that letter C is equivalent. Now I have multiple pieces underneath the root symbol, the radical symbol. So I'm going to have to take the fourth root of each of those separately. So the fourth root of 16 is 2, and you can use a calculator to find that. And then I'm going to do the x. The x has an exponent of 5, so that's my numerator, and then my index is 4, so that's my denominator. And I do the same with y. Y, my exponent is 2, so that's my numerator, and then an index of 4, that's my denominator. And then last I do that with z, and z has an exponent of 6, that's my numerator, and my index is 4, so that's my denominator once again. And so now looking at my answers, they go through and simplify these fractions this time. So I have the 2. 5 over 4 doesn't simplify anymore, so that stays the same. And then 2 over 4, that simplifies to 1/2. And 6 over 4 simplifies to 3 over 2. And so I just reduced my fractions, and that leaves me with a final answer of C. Okay, this part's very similar. I have an invisible index of 2, so I'm just going to go ahead and write that in. And then I'm going to have to put my x. It has an exponent of 2 and an index of 2, so that fractional exponent is 2 over 2. My y has an exponent of 3 and an index of 2, so that fractional exponent is 3 over 2. And then z has an exponent of 5 and an index of 2. And then I look and I can only simplify 2 over 2, which is the same as 1. However, we don't have to write x to the first. We can just write it as x, and the exponent of 1 is assumed. It's invisible there. And then my other 2 fractions I can't simplify anymore, so I leave y to the 3/2, z to the 5/2, and that leaves my final answer of A. Number 5, I have 23 to the negative 1/2. I'm going to move, first I'm going to get rid of this negative exponent. So that means I have to put the 23 to the 1/2 in the denominator, and that'll make it positive. And now I'm going to convert it back into a radical. So that means I'm going to have, the denominator is a 2. So I'm going to have an index of 2, and then my numerator is a 1, so I'm going to have an exponent of 1 underneath. 23 to the first power is just 23, and then also it's assumed to be a square root when you don't write anything there. So that's going to make my final answer B. And this one's the same idea. I'm just going backwards now. So I'm going to have the 5 under the square root. And then it has an exponent of 8 because that's the numerator. And it's going to have an index of 6 because that's the denominator. And so that leaves me with a final answer of A. So I look at this problem and I see all of the fractions have a denominator of 3. So that means all of these, when I put it into radical form, is going to be the cubed root. So 27, that's going to be raised to the first power, which is just 27. And then I'm going to have x raised to the first power, which is just x. And then I'm going to have y squared, because that's the numerator of the fractional exponent. And then I'm going to have z to the 4th, because that's the numerator of the z fractional exponent. So I'm going to go ahead and just simplify this now. The cube root of 27 is 3, because 3 times 3 is 9, times 3 is 27. The x underneath the cube root can't be simplified anymore, so I'm just going to keep it underneath. Same with the y squared. Now, the z to the 4th, that exponent is bigger than my cube root. That was an improper fraction. And when that happens, I can simplify that further. So z to the 4th, that's the same as z cubed times z. And when I take the cubed root of z cubed, that's just going to leave me with z. And then the cube root of z, I can't simplify that any further. So that means I'm going to have a z out front from taking the cube root of z cubed, and a z left underneath. Another way to think about that is 3 goes into 4 once, so 1z goes out front with a remainder of 1, and that remainder remains underneath the square root. So that gives me a final answer of B. This problem is very similar to the last one, but the first thing I want to do is simplify the fractional exponents as much as possible. So I'm going to have to distribute this 1/4 to all of the exponents. So 81 is just going to be raised to the 1/4 now. And then here, I have to multiply my exponents. So 1/4 times 2 is 1/2. So I have x times 1/2. And then y to the 6/4. And z for 4/4. So 81, the fourth root of that, which is the same as raising it to the 1/4, is 3. And then x to the 1/2, that's the same as taking square root of x. Y to the 3/2, because that 6/4 reduces to 3/2. That's going to be underneath the square root also. So I'm going to have y cubed underneath because the cube was in the numerator. And then here I have z to 4/4. That simplifies to 1. So I just have a z. And there's no 2 in the denominator, so that just is a z out front. And then I have this invisible 2 for my index, and I can see x, I don't have any x's left over to pull out, but I can pull out 2 goes into 3 once, so I'm going to have a y out front with a remainder of y underneath. And that's going to be my final answer, B. Okay, this problem here, you're going to want to remove the parentheses first to simplify it. And to do that, I have to think about distributing the fractional exponent. And so when I do that, I multiply exponents. So here, 5 times 2/5 is 2, so I'm going to have x squared. And then y has an exponent of 1, so 1 times 2/5 is 2/5. And then 3 times 4/3 here is 4. So it's going to be z to the 4th power. And so now I look at my answers and they have radicals in them instead of the fractional exponent, so I'm just going to have to simplify it a little further. X squared. And z to the 4th, there's no fractional exponents there, so I'm not going to mess with them. However, y does have a fractional exponent, so y is underneath a radical, and the numerator is a 2, so it's going to be y squared, and the denominator is a 5, so that's going to be my index out front, and that leaves the letter A as my final answer. Once again, the first thing I want to do here is remove the parentheses, so it's going to involve taking 1/2 times 3 and 1/2 times 2, since they're all exponents. So I'm going to have w, 3 times 1/2 is 3/2, and then x, 1/2 times 2 is 1, and then y, 3/2 over 2/3 is 1. And then today, 3 times 2/3 is 2. So then I just look to see how I can simplify any remaining fractional exponents into radicals. And so here, we're going to look at w. W has a fractional exponent of 3/2. So that means I'm going to have a square root with a w cubed underneath. And then x to the first is just x, y to the first is just y, and z squared comes down out front also. So then I have to take it one more step. I have this invisible index 2. 2 goes into 3 once. So I'm going to have a w out front with 1 remaining. So I have 1 remaining underneath. And then I have my x, y, and z squared out front. Now typically you're going to write these in alphabetical order like they do in number 10, which is letter D.